Hello everyone and welcome to our financial econometrics project presentation. My name is Nidhi. Today we will be walking you through our interactive time series forecasting dashboard which we built using Python and Streamlit. Our dashboard implements three core econometric models: OLS autoregressive, ARIMA and GRACH, and allows users to download stock data, estimate models, generate forecasts and compare performance in a single interface. The goal of our dashboard is to make financial time series modeling intuitive and interactive. Instead of running separate scripts, user can simply choose a stock ticker, date range, frequency, and model orders, and the dashboard handles everything automatically. It retrieves data from Yahoo Finance, computes log returns, estimates the models, produces fitted values and forecasts, evaluates accuracy using RMSE and MAE. It also generates GRACH-based volatility forecasts, which are essential for understanding risk. Let's start by looking at the sidebar. Here the user can enter a stock ticker such as Apple, start and end dates, data frequency, be it daily, weekly or monthly, forecast horizon, ARIMA orders P, D or Q, GRACH orders P and Q. We also added a validation check, so the end date must be after the start date. Once the user click Run Models, the dashboard downloads the data and begins processing. After running the models, the first thing the dashboard displays is the price series. This gives the user a quick visual overview of the stock behavior over the selected period. Below that, we show log return series, which is what all our models are estimated on. Log returns are standard in financial econometrics because they are additive over time and tend to be more stable than raw prices. In the first tab, mean models and accuracy, we start with OLS autoregressive model. The user chooses the lag order P and we estimate the current return RT as a function of constant C plus a series of weighted past returns from lag 1 through lag P, ending with error term epsilon T. We display the full model summary, including coefficients and diagnostics. Then we plot actual versus fitted returns, which helps user visually assess how well the AR model captures return dynamics. We also compute RMSE and MAE for the fitted values. These metrics quantify in-sample accuracy of the model. Next, we estimate the ARIMA model, which generalizes AR by adding differencing and moving average components. This allows the model to capture more complex dynamics. Just like with OLS, we show the model summary, fitted versus actual returns, and the accuracy metrics. In many cases, ARIMA achieves lower RMSE and MAE than the simple AR model.
Hello everyone, my name is Fazil. So for both OLS and ARIMA, we generate multi-step ahead forecast of returns over the user selected horizon. Then we convert those return forecasts back into price forecast using cumulative log returns. This gives users an intuitive sense of where the stock price might move in the future. So both returns and prices forecast are plotted, so users can visually compare the forecast paths. Then we move on to the GRACH models. So for this GRACH volatility modeling, the second tab focuses on volatility, which is a key feature of financial time series. Returns often show volatility clustering, periods of high volatility followed by more high volatility. So to model the volatility of the returns, we use a GRACH PQ specification. This equation estimates the current conditional variance, the sigma square T, as a function of three parts: a constant baseline omega, the arc terms, which capture the impact of recent market shocks or news from previous periods, and the GRACH terms, which represent the persistence of past volatility. Essentially, this allows the model to account for the way risk changes and clusters over time. So we estimate the model using the ARC package and display the full summary. Then we generate a variance volatility forecast for the same horizon as the mean models. So this plot helps users to understand expected future risk, something that AR and ARIMA cannot capture because they assume constant variance. Now we move onward to tab 3, which is of model comparison. So the third tab brings everything together. First, we show a table comparing RMSE and MAE for OLS and ARIMA. This makes it easy to see which model fits the data better. So, below that, we display a combined forecast table that includes a OLS return and price forecast, ARIMA return and price forecast, and GARCH variance and volatility forecast. We also added a CSV download button so users can export all forecasts for further analysis, for example, computing value at risk or feeding the results into portfolio optimization. So to conclude, our dashboard integrates data retrieval, econometric modeling, forecasting, and visualization into a single interactive tool. It demonstrates how AR, ARIMA, and GARCH models behave on real financial data, and it provides a practical, user-friendly environment for exploring time series dynamics. So, thank you for watching our presentation.